So to start the competition, we'll start with our first presenter. It's going to be Matthew Bronnimann. So come on up. So I'll just say a few words about Matthew before he begins. He's a third-year doctoral student. You have that already? Okay, in the Department of Immunology, College of Medicine. So with that, we welcome him to the stage, and let's give him a round of applause before he begins.
Thank you. My research focuses on understanding human papillomavirus, or HPV, specifically understanding how this virus penetrates the membranes of cells so that it can infect them. So why do we care about HPV? Because HPV infection is the cause of about 5% of all human cancer cases worldwide, including 99% of cervical cancer cases. All told, HPV infection causes about 275,000 deaths per year. There are actually about 15 distinct types of HPV that can cause cancer. We call these types high risk, and my lab studies these high risk types. So even though there is a vaccine against HPV, HPV is not a defeated virus. The Gardasil, or HPV vaccine, only protects against 2 of the 15 high-risk types of HPV that can cause cancer. These 2 types are the baddest of the bad, and they alone account for 70% of cervical cancer cases, but the vaccine still does not protect against the other 13 high-risk types. The vaccine also costs about $400. This makes it practically unobtainable in the developing world. Unfortunately, this is where the vaccine is needed most, as 88% of cervical cancer deaths occur in the developing world. Additionally, condoms have limited effectiveness in preventing HPV infection because, unlike other STDs, which are spread through bodily fluids, HPV can be spread through skin-to-skin contact between areas that are not protected by a condom. So now I want to show you what the villain of this story looks like. This is what HPV viruses look like underneath an electron microscope. The virus is essentially a spherical shell of protein with viral DNA buried in its center. These viral particles are what need to penetrate the membranes of cells to infect them. Here's what's known about how this happens. First, the virus binds to the surface of a cell. The virus then gets enveloped by the cell's membrane and brought into the cell in a membrane-bound vesicle called an endosome. Once in the endosome, the virus somehow penetrates that membrane to enter the fluid center or cytoplasm of the cell. Once in the cytoplasm, the virus can make its way to its final destination, which is the nucleus. And once in the nucleus, it can express its genes, it can replicate, and unfortunately, it can cause cancer. So the focus of my research has been on understanding this step, how the virus crosses the endosomal membrane, and determining if we can stop this process with drugs. Much to our surprise, we discovered that the virus can only cross this membrane during the short period of time when a cell is actively dividing. During this cell division, cells undergo thousands of different changes, and we discovered that 1 or more of these changes sends a signal to the virus that allows it to cross this membrane. We also found that using drugs that prevent cell division, we can totally block HPV infection by trapping the virus in the endosome. Going forward, we hope to be able to develop drugs that can block the virus from receiving the signals it needs to cross this membrane while still allowing the cell to divide. If we can do that, we believe that we can develop low-cost, effective anti-HPV drug treatments that could save lives and help make cervical cancer a thing of the past. Thank you.
Woo!